It seems like every day we hear about AI doing something more and more incredible.
Yeah,
Right, like AI that can write you a poem or even generate computer code.
it's pretty wild.
But what really got me thinking is how some of these AI systems, like these large language models,
LLMs.
yeah, the LLMs can do things that seem like they need,
Real world knowledge.
yeah, like giving someone driving directions across a city.
Right.
So it really begs the question, like, do these LLMs actually understand the world like we do?
Yeah.
Or are they just really good at making us think that they understand?
Yeah, are they just kind of tricking us with all this?
Exactly. So that's what we're diving into today.
It's going to get deep.
Oh, it gets deep.
We've got some really cool research from MIT scientists who took a deep dive into this whole question of how these LLMs work.
Yeah, and what they found is pretty fascinating.
It really is.
So I think to start, it's helpful to understand what we're dealing with here.
Okay.
So these researchers focused on a specific type of LLM called a transformer.
Like GPT-4?
Exactly, GPT-4, that's a transformer.
Mm-hmm.
And in their research, they trained these models on this massive data set of taxi rides in New York City.
Okay.
And they focused on the sequence of turns that each taxi took on these rides.
Interesting.
And you'd think that to be able to navigate a city, like to give someone directions, you'd need to have a map.
Right, you need some sort of spatial representation.
But here's the thing. These transformer models were able to give turn-by-turn directions almost perfectly
Wow.
without ever having an explicit map.
So how is that possible?
Right. It seems like they know more than they actually do.
Oh, it's a great illustration of how these models can sometimes fool us into thinking they understand more than they really do.
Okay, so give me an example.
Okay, well, imagine a parrot reciting Shakespeare.
Okay.
It's impressive, sure. But does the parrot actually understand the meaning behind the words?
I see what you mean. It's just mimicking, right?
Exactly. And in a similar way, transformers like GPT-4, they're trained to predict the next word in a sequence. So they get really good at sounding like they understand, but that doesn't necessarily mean they've actually grasped the underlying logic of the world.
So how did the researchers figure out if these models were truly getting it or just playing a really convincing game of pretend?
They came up with these really clever experiments using something called deterministic finite automata.
Deterministic what?
Deterministic finite automata, or DFAs.
DFAs, got it.
And I know that sounds really complicated,
It does.
but just think of it like a flowchart with clear rules about how to get from one step to the next.
Okay.
So you're at a certain point, and there are very specific paths you can take.
I see.
Like if you're navigating a city, you have to choose which street to turn onto at each intersection.
Right. Or like playing a game.
Exactly. Like Othello, you can only make certain moves based on the current state of the board.
So these are all examples of DFAs?
Yes.
So they use these DFAs, these rule-based systems, as a way to test whether the AI understood the underlying logic, not just the patterns.
Exactly.
But wouldn't just looking at how accurate the AI is be enough? Like if it's giving the right directions, isn't that all that matters?
Well, not necessarily.
Mm.
Remember that Connect 4 example we were talking about?
Yeah.
A model can actually learn to predict valid moves in Connect 4 without really understanding the rules of the game.
Oh, wow.
So the MIT researchers took things a step further.
Okay.
They actually developed 2 new metrics
Okay.
that specifically look at how well an AI is able to build a coherent model of the world.
Interesting.
They call these metrics sequence distinction and sequence compression.
Sequence distinction and sequence compression.
Yeah.
So tell me more about these.
What would they mean?
So sequence distinction basically means that the model needs to be able to tell the difference between different situations.
Okay.
So if you show it 2 different Othello boards, it should recognize that they're different and lead to different possibilities.
Makes sense.
Not just see a bunch of black and white pieces.
It's about recognizing those subtle differences that matter.
So it's not just seeing the pieces, it's understanding what those pieces mean.
Exactly. And sequence compression. This tests whether the AI understands that identical situations should have the same possibilities.
Okay.
So if you have 2 Othello boards that are exactly the same, the AI should understand that the same moves are available in both cases.
Got it.
It's a way to check if the AI is thinking logically and consistently.
So the researchers had their test subjects,
Right.
2 different types of transformers. One was trained on like random sequences.
They're like wandering around a city aimlessly.
Okay. And the other was trained on strategic choices like,
Like picking the shortest path.
okay.
Something like that.
So they had their transformers, they had their evaluation tools.
Yeah.
What happened when they put it all together?
Well, that's where things get really interesting.
Okay, let's hear.
So in the Othello experiment, The transformer that was trained on those random sequences
Hmm.
actually did a better job of building a coherent world model than the one that was trained on strategic gameplay.
Wait, really? That seems counterintuitive.
It does.
So are you saying that a model that was just kind of messing around
Yeah.
actually understood the game better than one that was trying to win?
In a way, yes. And it highlights how important it is for these models to explore a wide range of possibilities, even if they're not always the best moves.
So it's like if you only watch expert Othello players, you might miss out on some of those more unusual but still valid moves.
Right.
But if you see random players trying all sorts of things, you get a more complete picture of how the game works.
Exactly.
That's fascinating. So did this pattern hold true for the navigation experiment too?
It did.
Really?
Yeah, the models that were trained on the shortest routes, or even those with slight detours.
Like you would have with traffic.
Exactly.
Okay.
They didn't do as well at creating that solid world model compared to the model that was just trained on taking random walks through the city.
Wait, hold on. Are you saying that a model that basically just wandered around New York City randomly knows how to give directions better than one that was trained on the most efficient routes?
It sounds crazy.
It does sound crazy. How is that even possible?
Well, it all boils down to the power of these deep learning models to find patterns,
Okay.
even in data that seems totally random.
So even without a logical map in their minds, they can still navigate?
Right, they've learned to connect specific sequences of turns with getting to certain destinations.
Okay, so let's go back to that NYC navigation experiment.
Okay.
At first, the model was giving directions with almost perfect accuracy.
Yep.
But then the researchers decided to kind of mess with it a little bit. They started closing off streets in the simulation, so the AI had to deal with detours.
And that's when things went downhill.
Yeah, what happened?
Well, this is where that lack of a true world model really starts to show.
Okay.
Remember those bizarre maps we talked about earlier?
Ones where like streets curve in weird ways and there are flyovers.
Yeah, and just physically impossible layouts.
Yeah, those were strange.
Well, those strange maps are actually a reflection of how jumbled the model's internal representation of the city really is.
Interesting.
So when it encounters a detour,
like a closed street.
yeah, it doesn't have a real understanding of the city's layout to fall back on.
Okay.
It can't reason about alternative routes because its knowledge is based on memorized patterns.
Not a logical understanding of how the city is actually structured.
All right.
So it's like the model built this imaginary version of New York City in its head based on the data it was fed.
Yeah.
But that imaginary city doesn't quite match up with reality. And when something unexpected happens, like a street closure, the model doesn't know what to do.
Exactly.
It's amazing how this research really shows the limitations of even the most advanced AI systems.
It isn't.
They can be so good at mimicking understanding.
Yeah, they can really fool you.
But they don't actually grasp those underlying rules of the world the way we do.
Not yet, anyway.
So it sounds like these transformers, despite being incredibly impressive, aren't quite ready to replace human city planners
Yep.
or taxi drivers.
Not quite.
What about other areas, though?
Like what?
Like playing games? Did the Othello experiment have similar results?
Oh, absolutely. Let's talk about that. Oh, yeah. It's like the AI was able to figure out how to play the game, but it didn't really get the strategy.
So it's not thinking like a human player would?
Exactly. And to really make this point clear,
Okay.
the researchers, they didn't stop with navigation and games.
What else did they do?
They tested these LLMs on something totally different.
Okay.
Logic puzzles.
Like those classic brain teasers?
Yeah. You know the ones where you have to figure out the seating arrangement or who
Yeah.
committed the crime based on like...
Oh, yeah, like the ones that start. There are 5 houses, each painted a different color.
Exactly. And they gave these LLMs a seating arrangement puzzle.
Okay.
And surprisingly, the LLMs, they did pretty well at solving them.
Really?
Yeah.
Even the ones that were just randomly wandering around?
Especially the more advanced ones like GPT-4.
Yeah.
But here's the kicker.
Okay.
When they applied those sequence distinction and sequence compression metrics,
Yeah.
the results were, well, not so great.
So even though they got the right answer,
Yeah,
they weren't really understanding the logic behind it
right. That's like they found a shortcut to the solution.
without actually knowing why it worked.
Yeah, a great way to put it.
So they were still relying on pattern recognition.
Exactly, just like in the navigation and game playing experiments.
But they weren't really building a model
A coherent and consistent model,
of the relationships.
the logical relationship.
Stuff.
They were solving the puzzle, but not really getting the logic.
I see.
It's a really important takeaway for anyone who's using AI or thinking about its potential.
You can't just assume that because it gets the answer right, it understands it.
Right. Impressive performance doesn't always equal genuine understanding.
We need to think more critically, ask more questions.
Absolutely challenge those assumptions about what these systems are really capable of.
So this research, it's really important. It's helping us understand the limitations of these really advanced AI systems.
Exactly.
So where do we go from here? What's next?
Well, I think for starters, we need to keep developing better evaluation methods,
Okay.
methods that go beyond just measuring how well the AI performs a task.
So not just focusing on whether they get the right answer.
Right. We need metrics that can really dig into how coherent and consistent the world models are that these systems create.
And we need to keep these limitations in mind, especially when we're using AI in real-world situations.
Absolutely, especially when the stakes are high.
We can't just blindly trust the AI.
Nope, no matter how impressive it might seem.
It's like we have this incredibly powerful tool,
Yeah,
but we're still figuring out the instruction manual.
that's a great way to put it.
We need to be careful. We need to be thoughtful about how we use AI.
Couldn't agree more.
And this research, it also opens up a lot of exciting possibilities for future exploration.
Oh, definitely.
What if we could actually design AI systems that were specifically trained to build these really strong world models?
Interesting, instead of just relying on pattern recognition.
Yeah, what if we could use these models to make some really cool scientific discoveries or solve those complex problems that need a really deep understanding of the world around us?
The possibilities are pretty mind-blowing.
It feels like we're just scratching the surface of what AI can do.
We are.
But as we keep going, we need to remember to be cautious,
Right.
to understand both the potential and the limitations of these really powerful tools.
Absolutely. The future of AI is really in our hands.
Wow, that's a powerful thought.
The more we understand about how these systems work, the better we'll be able to guide their development and use them to help humanity.
I like that.
It really makes you think, like, what does all this mean when we use LLMs out there in the real world?
Yeah, like if they can get tripped up so easily by something unexpected, how much can we actually trust them?
It's a huge question, especially as AI is becoming a bigger and bigger part of our lives.
So these transformers, even though they're really impressive,
Oh, they are.
they're not quite ready to take over the world.
Not just yet.
Well, this has been an incredible deep dive. It's definitely given me a lot to think about.
Me too.
It's a good reminder that we should never stop questioning, never stop exploring and pushing the boundaries of what we know.
Absolutely, about the physical world and the world of AI.
Thanks for joining us on this journey.